Hello everyone, in this video we will see linear algebra. In that we are going to discuss elementary transformation of matrices. So before understanding what is mean by elementary transformation of matrices, let us understand first what is mean by matrix. So as we know, matrix means it is the arrangement of rows and columns in a bracket. Suppose, for example, if I consider one matrix A is equals to 2, 3, 4, 5. So this is what we call it as matrix, because it is the arrangement of rows and columns in a bracket. So remember this horizontal line of numbers, that is 2, 3 we call it as R1, 4, 5 we call it as R2. Together R1 and R2 we are going to call it as rows. That is, row means horizontal line of numbers. Similarly, this vertical line 2, 4 this is C1, 3, 5 this is C2. Together we are going to call it as columns. That is, vertical line of numbers we are going to call it as columns. Next, in this corner we are going to mention order of this matrix. So in this order always first comes number of rows. So next comes here number of columns. Therefore here how many rows are present? 2 rows. So it is 2 cross. How many columns are present here? 2 columns. So here 2. Therefore 2 cross 2 indicates order of which matrix? A matrix. Next, inside this matrix some numbers are present. That is 2, 3, 4, 5 are called elements of matrix A. Therefore, matrix means what? It is the arrangement of rows and columns in a bracket. Now, elementary transformation of matrices. So this elementary transformation of matrices is used to find equivalent of matrices and also used to find inverse of matrix. So in this elementary transformation of matrices, there are 6 rules are there. 3 for elementary row transformation and 3 for elementary column transformation. So in this row transformation, only rows of the matrices are transferred and no changes are made in the columns. Please remember that. Only we are going to change the rows, but we are not going to change the columns in row transformation. Now let us understand rule number 1. So what is that rule number 1? Any 2 rows are interchangeable. That is, Ri interchanges to Rj. So this means in the given matrix, any 2 rows we can interchange. For example, this is one matrix A is equals to, in this matrix we are going to interchange R1 and R2. Applying R1 interchanges to R2 means in place of R1 we are going to write the R2 elements, and in place of R2 we are going to write the R1 elements. Clear? So now if I apply this R1 interchanges to R2, so that time keep this R3 value as it is, 4, 3, minus 1. Next we can see what I said, in place of R1. In place of R1 we are going to write the R2 elements. What is that R2 elements? 1, 0, 8. We are writing in place of R1, 1, 0, 8. Similarly, in place of R2 we are going to write R1 elements. You can see here, in place of R2 we are going to write the R1 elements. That is 2, minus 1, 3. So this is the rule number 1. So What is that? Rule number 1, in the given matrix, any rows, only two rows, any two rows we can interchange. Next, rule number 2, all the elements of any row can be multiplied by any non-zero number. That is, Ri changes to k into Ri, where k is not equals to 0. So k means any number, leaving 0, any number we can take it here. For example, A is equals to, this is the given matrix. So here I am going to apply R2 changes to 2 times of R2. So that time we are changing only second row. So that time first row as it is we are going to keep. Third row also we are going to keep it as it is. Only for R2 elements we are going to multiply with 2. Therefore 2 into 1 is 2. Next 2 into 3 is 6. Next 2 into 2 is how much here? 4. So after applying this rule, this given matrix becomes 2 1 minus 3 2 6 4 and 5 0 1. So this is rule number 2. That is, all the elements of any rows can be multiplied by any non-zero numbers. Remember, whichever the number here you are taking, don't take 0. K should not be 0. Next, rule number 3. All the elements of a row can be added to corresponding elements of another row multiplied by any non-zero constant. That is, Ri changes to Ri plus k Rj. Again remember, this k should not be 0. So let us understand rule number 3 with one example. So this is one example. What is that? A is equals to 1 3 2 first row, 4 1 minus 2 second row, 1 4 2 third row. So here we are going to apply the rule number 3. R1 changes to R1 plus 2R3. So here we are changing only first row. Because of that reason, second row as it is we need to keep. Third row also we need to keep it as it is. Only first row we are changing. So remember here what is there? First, this R3. This R3 elements we need to multiply by 2 first. So now multiply. First, 2 into 1 is 2. 2 into 4 is 8. 2 into 2 is how much here? 4. So this we are going to add with the R1 elements. What is the R1 element? First element is 1. Second element is 3. And the third element is 2. Therefore, 1 plus 2 becomes 3. 3 plus 8 becomes 11. 2 plus 4 becomes how much here? 6. Therefore, we can see the first row. 3, that is 3, 11, 11 and 6. So, this rule number 3. This means we can multiply any row with a constant number. We can multiply any row. So, here this third row we are going to multiply with the constant number, and then we can add this row with another row. After that, this row we can add with the another row. In this example, we are adding with row 1. So this is rule number 3. Next, elementary column transformation. So in column transformation, only columns of matrices are transformed. Only columns of the given matrix are transformed and no changes are made in the rows, and we are not changing the rows. So here also there are 3 rules are there. Let us understand rule number 1. What is that rule number 1? Any two columns are interchangeable. That is, Ci interchanges to Cj. So this means in the given matrix any two columns we can interchange. For example, this is one given matrix. Here what we are interchanging, C1 interchanges to C2. This means in place of C1 we are writing this C2, and in place of C1 we are writing this C2, and in place of C2 we are writing this C1. Therefore you can see first column becomes 102 because in place of C2 we are writing, in place of C1 we are writing C2, 102. Next second column becomes 123 because in place of C2 we are writing C1 elements 1 2 3, and C3 we are not changing, therefore keep this C3 as it is, that is 2 4 1. So this is rule number 1. Any two rows in the given matrix we can interchange. Next, rule number 2. All the elements of any columns can be multiplied by any non-zero number. That is, Ci changes to KCi, where K value should not be 0. So it means any column we can multiply with any constant number. Any column we can multiply with any constant number, but remember this number we should not take it as 0. Leaving 0, other numbers we can take. For example, A is equals to 2143. Here what we are applying, C2 changes to 3 times of C2. We are changing C2 column, therefore first column as it is 2 4. Next, multiply C2 column with the number 3. 3 into 1 is 3. 3 into 3 is how much here? 9. So this is rule number 2. Next, rule number 3. All the elements of a column can be added to corresponding elements of another column, multiply by any non-zero constant. That is, Ci changes to Ci plus Kcj, where K should not be 0. For example, A is equals to, this is one given matrix 1 1 3, first row, 2 1 2, second row, 1 0 2, third row. Here we are applying the third rule for second column. Because of that reason, first column as it is 1 2 1, last column also as it is 3 2 2. So apply the third rule for the second column. So here first column multiply by 2. So what is the first column? 1 2 1. First I am going to multiply by 2. So 2 into 1 is 2. 2 into 2 is 4. Next 2 into 1 is 2. Next, this element we are adding with the second column elements. What is the second column? First element is 1. Second column, second element is 1. Second column here, third element is 0. Correct? Therefore 1 plus 2 becomes 3. 1 plus 4 becomes 5. 0 plus 2 becomes how much here? 2. Therefore we can see which column we are changing here? Second column, by applying the third rule. Therefore second column becomes 3 5 2. Correct? 3 5 2. So this means we can multiply any column with a constant number. Rule number 3 means any column we can multiply with a constant number. In this example, first column we are multiplying with 2, and then we can add this column with another column. Next, we can add this column with the another column. In this example, this column value we are adding with the second column. So that is the rule number 3. Therefore, remember, in this elementary transformation of matrices, there are two parts are there. First is elementary row transformation and the second one is elementary column transformation. So in this elementary transformation of matrices, there are 6 rules, 3 for elementary row transformation and 3 for elementary column transformation.